Okay, the first thing I want to do in this video is to look at how to notate sine theta times sine theta, which is going to be sine theta squared. We can write it like this, but I rarely see sine squared written like that. It's usually written this way. So be sure that you know exactly where that squared needs to be. I'm going to show you a mistake that some students make. This is the wrong way. Sometimes students will put the squared after the theta, and that means theta times theta, and then take the sine of that. And that is not the same thing as what we have over here. So be sure that when you're using the Pythagorean identities, that you know how to properly notate a trig function squared. Okay, the next thing I want to do is to look at cofunction identities. And we've seen before how the sine of 30 degrees is equal to the cosine of 60, right? These numbers here just kind of swapped. And that is part of what is called your cofunction identities. The sine of a 20-degree angle is going to equal the cosine of a 70-degree angle. So we're going to work with some problems using these cofunction identities. Problem 1, I'm asked to find a cofunction with the same value as sine of 46 degrees. So according to my reference sheet, sine theta is equal to cosine of 90 degrees minus theta. And I'm going to substitute 46 degrees in for theta. So I'm going to end up with the cosine of 44 degrees. Problem 2, find a cofunction with the same value as the cotangent of pi over 6. So I'm looking at this formula right here. So in place of theta, I'm going to put pi over 6. And I need to change 90 degrees into radians. That's pi over 2. So I subtract this and I get pi over 3. The directions for my next set of problems says to use an identity to find the exact values of the following. Do not use a calculator. So first of all, as you look through all of these problems, what you should first of all be looking for is that all of the angle measures are the same. And on problem 3, they are. So that means that I can use reciprocal identities, quotient identities, Pythagorean identities, any of these identities that allow me to have both of my angle measures being the same. So for problem 3, what I would like to do is to use a reciprocal identity, because I know that cosine and secant are reciprocals. And I can use either one of these to substitute in. I kind of like to keep cosine the same and then write secant as 1 over cosine. You can put the cosine over 1, and that way it's a little bit easier to see that your cosines are going to cancel. So that ends up being 1. Problem 4, we're given sine and cosine, and we're asked to find tangent. And I know that a quotient identity is going to relate all 3 of those. Tangent is sine over cosine. So now that I've substituted in sine and cosine, I need to simplify this. And there's a couple of different ways that you could go about simplifying. I'm going to multiply numerator and denominator by 7. That way I can have these secondary fractions to cancel out. And my numerator is now 5. My denominator is 2 square root of 6. And now I can just rationalize my denominator and get 5 times the square root of 6 over 12. Now I want to look at another way to do this problem. I'm going to rewrite this as a division problem, like you would write division of fractions in elementary school. And you know that when you're dividing fractions, you can keep the first fraction the same, change division to multiplication, flip the second fraction upside down, and then you can see the 7s are going to cancel. And now I have 5 in my numerator, 2 over square root of 6 in my denominator. Then rationalize your denominator. You have 5 times the square root of 6 over 12. Problem 5. I'm given the sine theta is 2/5, and I'm asked to find sine theta times cosecant theta. Well, first thing I notice is that these are reciprocals. So sine theta is I'm going to keep the same. I'm going to write cosecant as 1 over sine theta. And actually, I don't even need the fact that sine theta is 2/5. This is going to cancel out, and that's going to equal 1, no matter what my sine theta is. Okay, problem 6. Notice I have sine squared and cosine squared at the same angle, so I don't have to worry about having different angle measures that I have to change. Sine squared plus cosine squared is going to always lead you to, first of all, hopefully, think about looking at a Pythagorean identity. And I can see here, sine squared plus cosine squared is equal to 1. So this is just going to be equal to 1. Problem 7, given the fact that theta is an acute angle and sine is 1/2, find the value of cosine of theta. Now, on these next couple of problems, problem 7 and problem 8, you're told that theta is an acute angle, and that's going to become more important later on throughout this course. And you'll see why that is later on, why we needed to be sure that we indicated that it was an acute angle. All right, I need somehow to relate sine and cosine, and my identity that's going to relate that is either going to be a cofunction identity or Pythagorean identity. And I don't have any information about that angle, so I think the easiest way to do this problem is to use Pythagorean identity. Sine squared theta plus cosine squared theta equals 1. And I know sine theta is 1/2, so I have 1/2 squared plus cosine squared theta equals 1. 1/2 squared is 1/4. I'm going to subtract 1/4 from both sides of my equation. And I need to take the square root of both sides. Now, normally when we take the square root, we'll want our answer to be positive and negative square root, but because I have an acute angle, I know I'm only looking for the positive square root. So cosine of theta is going to be the positive square root of 3/4, and that's just the square root of 3 over 2. Okay, problem 8 is very similar to problem 7. Instead of solving for cosine, you're given cosine and asked to solve for sine. So we're going to skip that one and go right on to problem 9. So what I have here is squareds. So I need to be looking at a Pythagorean identity and see if I can somehow work with that. And I'm given secant and tan squared. So I'm going to be dealing with this formula right here. Go ahead and write this down. And there's more than one way to do this problem. I could take secant squared and substitute in this whole thing, right? In place of this, I am going to substitute in this. So I'm going to have tangent squared of 45 degrees plus 1 minus tangent squared of 47. Oops, those are supposed to both be 47 degrees. So tan squared 47, tan squared 47 are going to cancel out, and you're just left with 1. Now that's one way to do the problem. Another way to do the problem is to go back over here to your given Pythagorean identity. And I know that if I were to subtract tangent squared theta from both sides of my equation, this would cancel. So I would have 1 equals secant squared theta minus tan squared theta. So secant squared minus tan squared is 1. So a couple different ways to do that problem. Okay, problem 10. Notice that my angles are not all the same. So I'm going to have to be changing these angles. And one of the things that you should notice right away is that these are going to be adding up to 90 degrees. So I'm going to be using a co-function identity. And I can change everything to 20 degrees, or I can change everything to 70 degrees. It doesn't matter which one you do. I'm going to keep everything with 20 degrees just because that's what I'm starting with. So cosine of 70, I can make the sine of 90 minus 70 or sine of 20. Right? So I have sine of 20 that I'm substituting in here. Now remember, I'm trying to change this. I'm trying to use a co-function identity for sine. That's going to be the cosine of 90 minus theta. So this would be cosine of 20 degrees. And I have cosine 20 degrees. So what I have here is sine squared of 20 degrees plus cosine squared of 20 degrees. Sine squared plus cosine squared is my Pythagorean identity that's listed first in this section of my reference sheet. Sine squared theta plus cosine squared theta is equal to 1. Okay, problem 11. Couple of things that you should notice right off the bat. One is that my angle measures aren't the same, so I'm going to have to deal with that. So I need to change both of them to 10 degrees or both of them to 80 degrees. And the second thing that you should notice is that you've got squareds here, so you're probably going to be using a Pythagorean identity. If you look a little bit closer, you can see that you've got a Pythagorean identity with tan squareds, and you've got ones with cosecant squareds. So we're going to need to change these. And again, it doesn't matter whether you change everything to 80 degrees or everything to 10 degrees. I'm going to change everything to 10 degrees. Cosecant theta is equal to secant of 90 minus theta. So this would be secant squared of 90 minus 80, which is 10. So now I have tangent squared and secant squared. So there's a couple of different things that I can do here. And I'm going to write down my Pythagorean identity that I'm using. Tangent squared theta plus 1 is equal to secant squared theta. And what I'm going to do is to replace this secant squared 10 degrees with tangent squared 10 degrees plus 1. Now you notice I have minus tan squared plus tan squared, both of 10 degrees. They're going to cancel out. 1 and 1 is 2. Problem 12, I need to change one of these two to end up with having the same angle measure. So I'm going to keep this is sine squared of 75 degrees, and I'm going to change this sine squared of 15, and that's going to be the cosine of 90 minus 15. It's going to be the cosine of 75. So now I have sine squared plus cosine squared. That's Pythagorean identity, and that's equal to 1. So 7 and 1 is 8. Problem 13. You can see that I've got different angle measures, and I've got 5 and 85 that add up to be 90. So I know that I'm going to be using a cofunction identity. So I can keep everything in terms of 5 degrees or everything with 85 degrees. I'm going to keep 5 degrees, right? So secant is going to become cosecant of 90 minus 5, or sorry, 90 minus 85, which is 5. Tangent, I'm going to change to cotangent of 5, and this cotangent of 5 is going to stay the same. So now I have cosecant squared 5 degrees minus cotangent squared of 5 degrees, and I need to relate those. So again, Pythagorean identity is going to tell me that cotangents and cosecants I can relate. And so here is my Pythagorean identity that I'm using. And I notice that I have cosecant squared minus cotangent squared here. So if I were to subtract cotangent squared theta from both sides of this equation, then here they would cancel out, and I would have 1 equals to cosecant squared theta minus cotangent squared theta. So this is equal to 1.